All right, we're going to give just a couple more minutes for people to trickle in, as this is the first session of the day. And again, we are going to look for some note takers. So if anyone would like to volunteer for that, that would be wonderful. We won't be able to start without that. Alrighty, I think we can get started here. Welcome everyone to the meeting of IPPM at IETF111. Thanks all for joining. We have a pretty packed agenda as usual, and so we appreciate your involvement and participation. Here is our note well. If you've been in other meetings so far this week, you've probably already seen this. Just please, if you haven't seen it before, take a moment to familiarize yourself with the contents here. This is essentially our code of conduct for how we work in the IETF. So we are here on MeetEcho. There's a Jabber room, but that's also more conveniently accessible in the chat panel within your MeetEcho. And we do have notes page started, but we do need a note taker still. So I'm going to sit on this slide as we wait for someone to volunteer to help take notes. Anybody? Mainly what we're looking for is just someone to kind of write down conversation on the different documents and who said what, so we have a good record of that. Is anyone able to help volunteer here?
Please.
we have a lot of people in this group, a lot of people participating. So if you want good quality records of what's going on, we do need a note taker. Anybody?
Someone doesn't want to do it during their talk or something like that, we can try to find two people or something. I don't know.
Yep, that's totally fine.
Tommy.
Amaya. Thank you very much. And
I've got something I need to finish in the next 5 minutes, and then I can happily update the things as we move on if you want.
Sounds good. All right, so we'll have Amaya and Gory help with that. Thank you. Very much appreciated. All right, let's move on. There's one quick thing before we get into the agenda. I sent out an email already about this to the group, but since it's very applicable to people in IPPM, I just wanted to highlight that there is a IAB workshop that's going to be happening in September on the measurement of network quality, specifically with a focus on what that means for end users. The submission due date is next Monday, so if you are interested in participating, you can just write up something very, very short about your thoughts on this topic, and there is a link to find more information here on the slide that you can get in our meeting materials. All right, so looking at our agenda coming up, we have first some updates on working group documents and then documents that we have spent a lot of time talking about in the working group already. A lot of that's going to be talking about the progress on our IOAM drafts to begin with, some of the other adopted work, and then some of the work that is developing in the group. And then once we get through that part of the agenda, which will be a little bit over the first half of the session, we have a number of proposals and lightning talks that we will get to. These will be around 5 minutes each. And with that, do we have any comments, agenda bashing, or should we move on to our content? All right, so let's start with the IOAM documents. Let me just pull up that. All right, hello, Frank. And Frank, are you fine with me sharing, or do you want to share the documents so you can advance the
No,
slides?
I'm very fine with you sharing.
Okay.
So I'm hoping for that. Apparently, I'm not ready to share. So this is a joint presentation between Tal and I. So I'm going to go cover the first and the last, and Tal is going to go and cover the flags draft and the direct export draft. So if you flip to the next slide. This one is about the in situ IOAM deployment. And next one. So this is a sister document to what we refer to as the data draft. So the draft IETF, IPPM, IOAM data, which is still in ISG review. There is a new version, the -14. And the -14 now also references this deployment draft because a lot of the ISG comments were around deployment aspects. And so people found that there is a benefit to also have deployment considerations at least referred to in the data draft. So there is a linkage between the two documents now, which is why I think the document pretty much raises in importance. From a content perspective, there hasn't been too many updates between the last revision and the revision 3. It was mostly around comments that we got, again, from various reviews, including the IESG reviews, so that we updated the security section and took care of that to go and discuss mitigating eavesdropping, attacks around time synchronization, because multiple people could go and use different clocks on different devices. That's been reflected in the latest version of the O3. And originally we started that document in OPS-AWG, which is why the title still carries the OPS-AWG title. Name and or word in the document title, but given that all the work has been happening around IOAM really in IPPM, and we had the same discussion with the V6 aspects in a similar vein, right? So we moved the work over into IPPM. We do believe that the right home for that document would be IPPM instead of OPS-AWG, so that we have all the experts here, we can do all the reviews here. And we believe that given also the linkage to the draft IPPM IOAM data, that we do want to go and progress the work here and hope for working group adoption of that particular document. And Tommy, I'm not sure how you want to go and drive things. Do you want to go through the entire presentation of the 4 drafts that we have, or do you want to go and have discussions individual on a per draft basis?
Let's kind of, since these have some questions here, let's take these kind of one at a time so we make sure we can come back to them. So yeah, this sounds fine to me. I think given the IESG review, it sounds like this needs to be progressed somewhere. If that's not going to happen in ops, then I think this does make sense. I guess I'd like to hear from the working group if anyone has objections to this happening in IPPM, and I'd be also curious to hear our AD's thoughts on this, given the process of the IESG review and how we want to schedule this.
I think it would be fine for this to come into IPPM, if that's what you're asking me, but maybe I didn't understand your question.
Yeah, I mean that as well as is this going to end up being like a dependency, or do we think like kind of a main IOM data document can go through just knowing that this will be coming after?
I don't have a great sense of what Ben's reaction to that would be. I would be in favor of moving IOM data forward regardless, even if it has to sit in the RFC ed queue forever.
Okay.
And to be honest, I haven't thought deeply my personal position on this and whether it needs to be normative or informative. If Ben is going to insist on normative, then I think we still drive forward, but that we get the document done from our perspective.
Sounds good. Ian, did you want to say anything here? Or are we good? All right. So I think, given no one else commenting, we will kick off a adoption call for this and move forward with it. Thank you. All right. So next we have Tal talking.
Hi. Okay, so we want to talk a bit about the flag draft and the direct exporting draft. So we'll start with a few words that are common to both of them. Next slide, please. So we had a very wide discussion in the last IETF meeting about security-related aspects of these two drafts, especially various attacks which were described by Martin. And we did quite a bit of homework in the design team. We discussed this a lot over our meetings. And we've added quite a bit of text to these two drafts. So we can see the main changes here. So we've already had one iteration of comments about the DEX draft. And we recently, in the last few days, also updated the flags draft to reflect very similar changes. So just very briefly, the main changes we're talking about are, first of all, related to what we're expecting from IOM encapsulating nodes in order to address these possible attacks, or in order to mitigate these possible attacks. The second thing is what we're expecting from IOM transit nodes in this aspect. There's also some text that talks about the fact that we want to avoid direct exporting being applied to exported traffic, okay, because we want to avoid kind of having nesting of direct exporting. And a very similar requirement is also described in the flags draft for loopback. And finally, there's also some text about the fact that we're expecting generally exporting to be applied to trusted nodes. So these are basically the main changes. There was quite a bit of text added to the two drafts. And we hope that we managed to address the main security-related issues that were mentioned. If there are any other comments related to these changes or related to these threats, we'd be happy to hear them. Okay, next slide, please. Okay, so that was the common part that was updated for both drafts, and now we're going to focus a bit about the flags draft, and then we'll talk a bit about the direct exporting draft. So basically the flags draft, the main changes we've had are related to security. So actually we haven't had many other changes in the draft. Other than the security related issues, we believe the draft is pretty stable. Once we see that the security related changes are stable as well, once we see there are no further comments related to this specific topic, we believe we'll be able to proceed to working group last call. So that's for the flag draft. Next slide, please. Okay, direct exporting. So related to this draft, we had two main open issues that we've been discussing for a while now. And we actually discussed them not only in the last IETF meeting, but also in previous IETF meetings before that. We haven't managed to resolve these, but we asked the working group chairs for some advice here. And for each of these two open issues, we can see the suggested resolution from the working group chairs. So basically, just a reminder, the first open issue was regarding the hop count field, whether we were going to have an explicit hop count field in the DEX option header. And right now, the suggested solution is to avoid this field, basically to be able to rely on the existing hop limit node ID data field, which was already defined in the data draft. So that was the suggestion for issue number 1. For open issue number 2, the issue was whether we want to have different option field lengths. Basically, so far we had two variants of the direct exporting option. One of them was shorter, the other was longer. And we also had a question about what would happen if we wanted to extend the direct exporting option in the future. So there were a few possible alternatives of how to proceed here, and the suggested solution in this context is to use the flags in the direct exporting option header in order to indicate which optional fields exist in this direct exporting option. So what we're going to do, assuming there are no further comments about that, the next step will be to define these specific flags, and also to define a registry for these flags. And once we update the draft with this change, we can probably proceed. Next slide, please. Okay, so that's the main next step. Once we see if there are any further comments, we can proceed and apply these changes based on the resolution to the two open issues, and update the draft accordingly. Any comments about generally either the direct exporting draft or the flags draft?
Yes, I'd like to particularly hear if any of the people who were bringing up some of the security issues for DEX and flags have read the updated versions, what they think about that. And then I'd also like to hear if anyone has any issues with the resolution to the two options that we discussed earlier. All right, Martin.
Yes, Tal, thanks for the changes. I do think that's addressed the most serious problems that I brought up a couple of meetings ago. I would not characterize these as necessarily attacks. Like I think one of the points of my presentation was that these things just sort of happen by bad luck. Although, of course, it could also be exploited as attacks. but that's a nit. I think the draft's moving in the right direction. I'm still a little tempted to retreat to my original sort of general concern about amplification. But like I think the new problems that have arisen have been addressed pretty comprehensively, and I would have to think a little bit more if they've actually also substantially addressed the amplification issue. But at this point, I'm happy with how things are progressing. Thank you for your work on this.
Okay, thanks.
Awesome. All right. Any other comments, thoughts from people? I guess, yeah, speak up if you have any objection to the proposed resolution for these two open issues. Otherwise, I guess we'll look forward to a updated document. Put that in there, and then we can kick this going forward. Okay, well, that's surprisingly easy. I wonder how many people here are asleep. All right. Shall we move on to the integrity document?
Yep, that's Frank again.
Okay. Yeah, thanks. And Tommy, you see that people are relatively quiet on this because this has been extensively discussed in the design team. And I believe we are happy with the resolution that you provide, given that we have a resolution for especially the questions around the DEX draft. So the integrity of IOEM data fields has been also discussed at length, and we know that in the past session we had a bit of a menu of options that we presented, and the recommendation was to go for, if you go to the next slide, to go what was originally method 3, and that method 3 was a method that used symmetric keys, but consolidated the signatures with the hash always into the very same field by iteratively reusing that field and kind of piggybacking on top. One recommendation was to go and use this method, but extend this method to not only use symmetric keys but asymmetric keys, and well, basically move everything else to backup so that in the second stage we can move it from backup to the trash can. That's apparently what we've done. So the new draft is focused on what used to be method 3, with using both symmetric keys or asymmetric keys. It doesn't really matter that much, because from what we're going to go and carry in the data plane, it's going to go look the same. Everything else has been moved to the appendix for now. And given that we kind of agreed, and we hopefully agree on that in this session, that we're going forward with this space-optimized key-based signing method. We are also in this draft proposing new IOEM options that are now integrity protected, because they are carrying what we call a subheader for integrity protection, and we're going to go and look at that in a second. And we also, given that we now have this solution in place, we also started to go and update. Again, that was a recommendation in the last session, and I think Greg was bringing that up, to go and expand a little bit on the overhead considerations for this particular option, and bringing in options how to go and drive down the overhead if people have a concern with like too much processing on a per packet basis that this integrity protection would bring. And one idea is obviously to go and only apply this to a subset of the packets, and I think this is also represented in the draft now. So if you go to the next slide, we'll get a glimpse at the new option types. So we have the original IOEM option to the right-hand side, and we have an integrity protection option to the left-hand side now, so kind of side by side. So we're going to go and create new option types for that. And if you look at the suggested values for the option types, you'll notice that, well, they all carry the first bit as 1. So it would be very easy if we allocate the option type values smartly, like we are suggesting here, to just look at a single bit and see whether the option type header for integrity protection would be there or not, that subheader. Flip forward one step, next slide, and we'll see that subheader. So that is going to go and be appended to the existing option type header, be it like E2E or be it POT or be it one of the trace option types. So given that we'll have multiple ways to go and use keys, so we'll always have this pair of a method to go and hash and a method to sign. And it might be a symmetric method to go and sign. It might be an asymmetric method to sign. And the approach that we took in order to allow for future flexibility and not be kind of prescriptive here or be too prescriptive is that we're saying we're going to go and have a couple of suites of a combination of hash method and signing method. And there's two proposed here to start off with, one for asymmetric, one for symmetric. There could be more in the future. Let's see what people feel is the right approach. The two are the ones that we also had as suggestions from the 02 version of the draft. And then, well, all of these methods need a nonce, and they need a signature field. And well, given that the nonce, depending on the method that you're using, and the signature has various variable length, there will be a length field in this whole thing. And the two go hand in hand from a length perspective. So we'll have a length field, a nonce field, and a signature field. And if you flip to the next slide, then you'll see how this subheader. Tommy, could you go to the next slide? Thank you. Then you'll see how this subheader will extend the existing IOM option types, the trace option type to the left-hand side, and to the right-hand side, the POT option or the E2E option. And so we're just kind of appending that particular option type header and making it a sub-option header and making it a new option that way. Next slide. So we hope that this addresses what we learned from IETF 110. So we consolidated into the method 3, expanded, put in symmetric and asymmetric options. There is an additional kind of dependency now, very much like with the deployment draft, given that people felt it is key that we have an integrity protection for IOM data. There is a reference in the IPPM IOM data 14 now to this particular draft because, well, we don't really have the integrity protection covered in the data draft in the original version, but we'll have an extension with additional options, much like we're extending for DEX or other things. We are extending here for integrity protection so that we have a related draft to the original draft that covers integrity protection for these options that are defined there. And we are hoping that this meets the needs and that we can go and also start a working group adoption call for that document. And I, well, appreciate comments, questions, whether this meets what people had in mind, because, well, we're navigating a little bit the territory of what people believe is required here, given that we started with a menu and we narrowed down the menu to a solution now, and we're hoping that this solution meets what people had in mind.
All right, yeah, just for myself, thank you for doing this. I think this does represent the direction that I was imagining. We do have some time here for comments and questions. I guess have people comment if you've read the most recent version, if you think this is the right direction. One question I'd have is, I think at some point we'll want to do a sector review of this to get the input. Sounds like something we'd probably want to do early on before we go too far down one particular road. And I guess the other question I'd have to the authors is how much implementation has been done of this so far? Is it still pretty early days on that?
So this is early days, given that this was more something that is piggybacking on top of what we have. It's from a hardware perspective, this is really hard to do. From a software perspective, maybe. But yeah, there is no implementation on that. So the open source reference code in VPP doesn't do it, and I'm not sure whether we have Justin here that drives the implementation of IOM in Linux. Maybe Justin, if you're here, you can go and speak up or show your hand.
Yeah.
Yeah, there he is. I'm not
So
sure whether you've done anything of that in
actually,
in the Linux kernel.
yeah. So IOM is in the Linux kernel officially. It's a news from 2 or 3 days, and it's gonna be available in the next release. So it's 5.14, which will be released, I would say, in 4, 5, or 6 weeks. So it's officially inside.
But do you have implemented any of the integrity protection options here?
No.
Okay.
Or I guess, what would the timeline for that be, even for just kind of doing experimentally? Because I think that's going to be important for understanding if the draft is good to go.
Yeah. Well, actually, I was going step by step because it's a huge part to make it inside the kernel. So I will have a look at it. Yeah.
Okay. All right. Any other questions, comments on any of these IOM documents?
So Tommy, how do you want to go and progress with that? Should we see whether we can go and adopt it, or do we want to go and leave it hanging? Because I think the question that we had, and you've seen the ISG comments, like yeah, it's referring to an individual draft. That's not even a working group draft, but we need a working group solution for this whole space. And I think so we need at least a placeholder to go and progress the work.
Yeah, and so Ian or Martin, correct me if you disagree, but my sense would be that next week we kick off an adoption call for both the deployment and the integrity documents. We get them adopted, but particularly for the integrity, we should gate progressing it beyond a working group document on both
for sure,
as well as implementation. So yeah, we need it adopted. We need to say, yeah, we're working on this, but it's going to be really important to have the experience implementing it.
And one thing that we might want to go do if we adopt it is we need to move it from an informational document to probably a standard struct document. Yeah. Okay, cool. Thank you.
Okay, I think we are done on time. Thank you, everyone. All right, so next up, we have Stamp Yang. I think I have the deck for that here.
Okay, great, thank you. Okay, so it's a long time not seen. We came back to this document and used the experience that we got and in stamp extensions. Next slide, please. So from 8972 stamp extensions, where we introduced their stamp session identifier, and that was an update to 8762. So now that was incorporated into their Yang data model, and that now becomes their key for their STEM session list, because the session identifier is unique for the STEM session sender, and in combination with their source IP address, session identifier provides globally unique identifier for the reflector. We removed the packet padding size because their 8762 base stamp specification defines symmetric packets of fixed size, and their definition or ability to generate packets of variable size provided by extra padding TOV that is defined in 8972 and extensions to STEM. So we continue addressing the early young doctor comments review that we have from a while ago, and edit references to 8762 and 8972 were appropriate, and did some editorial and neat cleaning. Next slide, please. So I mentioned that we introduced STEM session identifier that was defined in 8972. So this is just a snapshot of the Yang data model that is a part now of their document. And that explains what the session ID is, as defined in RFC 8972, and how it's used by providing their unique key for STEM session sender, because it's assigned locally, so it's locally unique. And then in combination with the source IP address, it provides their unique key for the session reflector. And as well, for the session sender, it's an argument for RPCs to start and stop test sessions. Any questions? Comments? Yes, Rakesh.
Hi, Greg. So the RFC 8972, the stamp session ID is 16-bit. So I don't know, here it shows 32-bit.
Ah, yes, you're right. My mistake. I'll fix it. Thank you.
Yeah, thanks.
Okay, next slide, please. Packet padding size and stamp extensions in general. Because base specification defines the fixed size packets, so that to create packets of other length, extra padding TLV should be used. And so hence the question, because this is an important part of testing, and seems that it's logical to be included in a stamp Yang data model. So, but at the same time, so that opens the question for how other extensions that define in 8972 to be reflected in a Yang data model. Should be they part of the same module, or reflected in a separate models that can be augmented to the stamp-based Yang data model. So this is an open question, and I would like to get your comments and thoughts. Yes, Rakesh, please.
Hi, Greg. So because the extra padding is a stamped TLV, so it's integral part of RFC 8972. So Young data model for it could say, could give a parameter to say the packet size, and this will allow us to test the various packet sizes, which is part of STEM.
Yes, that was so. Authors we talked about it thought is yes, it's explicitly does not require. It only will be a reference in a data model saying that this uses extra padding TLV. But with that, what about other extensions? So should we include them in this base Yang data model, or just their models can be defined as a separate modules in the same document, or just let people bring additional models if they find it's necessary?
My personal opinion is a parameter in the stamp model with default size padding 0.
Yes, that we agree. That's our thinking too. That for padding, the base, the default is no padding, and then there is an option to define additional padding through the extra padding TLV. But 8972 defines other TLVs. For example, that class of service testing that supports, or location information. So the question we have to the working group is how these TLVs to be reflected in the base stamp Yang data model. Would you suggest to have it as an integral part of it and use it as a feature? And then if it's enabled, then there will be an element of data model that defines and allows to read it, or just leave it outside and only include support for extra padding TLV.
Yeah, so since RFC 8972 is optional stamp extensions, so Yang models should also follow the same spirit.
Okay, so you suggest your opinion is that because we already have RFC 8972, and since we already reflect some elements of some elements defined in 8972, then we should go and include in this data model all the elements.
As optional extensions, just the way
Right, correct.
8972 is.
Yes, so make them optional in the data model, but include them all. Yes, that makes sense. Okay, I saw Footer raising his hand and then just disappearing.
Yeah, I was just about to agree with you, but since it was already agreed to between the two of you, I thought that was
no. It's good to have the sense that there are more than two people agree with themselves.
Yeah, I definitely agree. I mean, the option should be included as well. So I think that's the right path. Hey, Greg, I did have one question. 8762, when it originally went out the door, was backwards compatible with TWAMP Lite. And that allowed for padding outside of the TLV. Does the Yang model, I'm sorry, I don't know this, does the Yang model support, did it support a current padding size beyond this TLV that's defined in 8972, and are we removing that?
Well, again, that was how we arrived at this question. That strictly speaking, 87.762 does not define how you do padding. But in 89.72, in extensions, we introduced the TOV that allows to not only to do extra padding TOV, but combine it with the other TOVs. For T1 polite, because it would not recognize their TOVs, it will treat them, or we expect it will treat them as padding. If T1 polite is a session reflector.
Right. Okay.
And in that aspect, 89.72 doesn't change what is put in the base in 87.62.
Okay. Thanks, Greg.
Okay. So thank you. Please. Let's discuss this on a mailing list if you have other opinions in regard to inclusion of extensions. But our thinking was that, as Rakesh and Footer suggested, to make this optional features and then support them as documented and defined in 89.72. So the next steps are continue working. Comments are welcome, and we'll try to make it ready for working group last call by the next meeting. Thank you.
Thank you, Greg. That sounds great. I think we are out of time on this one. We can move ahead. So the next slot we had was to chat about the newly adopted SRPM document. Rakesh, I don't see slides from you here. Did you have those? Or would you like to present?
No, I hadn't updated it. It was there.
Which... What's the name of the slide deck on that?
It's stamp SRPM.
Yeah, I did approve those, so they should be there.
Ian, if
Yeah, I
you
checked.
have...
I checked. It was online as well.
Let's see. I no longer see them. Ian, do you see them?
Yes, simple stamp for SRPM. Would you like me to?
If you could share it.
Yeah. Sure. Share screen. Yes. Oh, that's not what I want. Okay. That's not perfect, but that'll work.
All right. Yeah. Hi, everyone. My name is Rakesh Gandhi, and presenting the stamp extension for SR on behalf of the authors listed here. Next slide, please. Yeah, so we'll review the updates in revision 00 and 01 in the newly adopted document. We'll just highlight the stamp-based work that's happening in other working groups as well, and the next steps. Next slide, please. So in revision 00, it's newly adopted by the IPPM working group. We address various review comments that we received during the working group adoption. So we updated the security section. We introduced a new error flag, D flag, wrong destination. There is node address TLB format has changed as well. We clarified TLB applicability to P2P versus P2MP. There were many other clarifications as well added in the draft. So please have a look and let us know your review feedback. And in revision 01, there were few loose items from remain from 00. One was the security section, man in the middle related in limited domains related comments. There was also a comment about destination address TLB in some scenario. It should be must. We added the new flag in INS section, and there were a few other minor editorial changes. So many thanks to the working group for all the review comments and suggestions and feedbacks. So I think draft is in a pretty good shape at this point. Next slide, please. So we also have stamp-based work in other working groups. So it's great that we have stamp work done in IPPM, and it's quite useful work. So we start to see the extensions we have in spring using stamp for PM there. So there was a working group adoption. The draft is adopted in spring now. We addressed various review comments there as well. There was discussion on whether it's informational or standard track document. And we welcome your further review comments and suggestions on that work as well. And many thanks for all the feedback we have received. We also have a new draft in MPLS / maybe PALS working group, and it's the encapsulation of stamp for pseudo-virus in MPLS networks. Again, this is 00 version, and we welcome your review comments and suggestions for this draft as well. Next slide, please. So at this point, we are seeking more comments, feedback, suggestions. More than welcome, appreciate it. Thanks. Any comments, questions?
Thank you. It sounds like me. Oh.
So I think next up we have IOM conf state, an update on that. And again, Ian, do you have the slides for these?
Let's
see.
Let me look. This one is not coming. I'm not trying to present directly to the tool, which maybe I'm seeing a few more slides than.
Right.
Yeah, folks want to have these available and want to present themselves, they're also welcome to.
Yeah. Joe, do you have the slides yourself?
Can you hear me?
Yes, we can. Do you have the slides for this?
The name of the slides is Ping IOM enabled IOM capabilities. I think it's already
I see.
On
Got
web
it. Yeah.
page.
It's just the title. All right, let me see if I can share that then.
Thanks. Yeah, I was looking for the wrong title as well.
Thank you.
Got it. Perfect. Here it is.
Yeah. Hello, everyone. It's Xiaoming speaking. This presentation is on echo request to reply for enabled in-situ OEM capabilities. I've presented the version 08 of this draft at IETF 110. This time, I present the latest version, version 10, which has also been submitted as 00 working group draft. Next slide, please. This is a summary of main updates from version 08 to version 10. Beer was added into the scope of this draft because Beer introduces a new multicast data plane. There's already an individual draft that specifies Beer encapsulation for IOM data, and a working group draft that defines the ping and the trace route for Beer. In addition, we add SR into the scope as suggested during adoption poll. Considering SR MPLS reuse LSP ping and SRv6 reuse ICMPv6, there's no new extension is expected. Another update we've made is to separate pre-allocated tracing and incremental tracing more clearly, because it's realized that mixed usage of the two tracing options is seldom. Next slide, please. During the adoption poll, there were two more discussion points raised. The first one is the recommended feasible method of IOM deployment to use PCECC SDN centralized controller. In the next revision, we'll clarify that in this draft, centralized controller means a controller that owns the enabled IOM capabilities of every IOM device within the network. Furthermore, we think this discussion point might be also relevant to IOM deployment draft. The second discussion point is it appropriate to use ISS instance or OSPF transport mode to carry the metadata of enabled IOM capabilities? It looks like a high requirement for all IOM devices to support multiple IGP instances. However, this discussion point is more relevant to LSR working group. Next slide, please. The author's plan is to submit new drafts on specific extensions and considerations. For example, security consideration to different pins, including IPv6 pin, MPLS pin, SFC pin, and Beer pin. These new drafts will be submitted to the working groups that own the relevant mechanisms. Next slide, please. Next steps for this draft. It's already been adopted as the IPPM working group draft. We ask for more reviews and comments, and we'll revise this draft to improve it. That's all. Thank you.
All right, thank you very much. Does anyone have any questions about what was presented here, or should we move on? Frank, go for it.
Yeah, I have one general high-level question. And that general high-level question is, how does this work combine with the work on IOM Yang?
IOM is used by the network management to configure the IOM encapsulating node. If the controller has already owned the IOM capabilities of every IOM devices within the network, then we don't need to have this tool. But if the controller has no information about the IOM capabilities of all IOM devices, then we need this tool to pin for the IOM capabilities of every IOM device on the path.
Yeah, thank you. But let me be more specific, right? So you're defining TLVs and sub-TLVs and particular structures on how you want to go and retrieve the data. It would be nice if we could go and have a proper data model for that. I think that's what I'm trying to say. And if we can go and sync that data model with the data model that we use for configuration and configuration retrieval with what we have in the Yang document. So if we can go and develop these things in lockstep as opposed to separated, it would really ease the job of an implementer. But anyway, we can take that to the list.
Okay, thank you. We'll consider it.
Just to be clear, so the purpose of this draft is to have the, I want to understand. So the purpose of this is to have the core, like formats for reporting capabilities in this document, and then the way that's encased in these various signaling protocols is going to be in the other drafts in the other working groups. Is that correct?
Yes.
Thanks.
All right, Cheng, and then we can move on.
I'd like to know that the security issue, did you just address them? Like I proposed
yes.
before. Yeah.
Yes, we have an update after we received the comments from you and other experts within the IPM working group. We have already updated the security consideration section after last adoption poll in November last year. Yes, we have already addressed it. And also, I want to note that with the new submitted draft on specific extensions, we also will consider security carefully. Thank you.
Okay. We'll go back to check the text. Thank you.
Very much. I think we can move on. All right, and next up, we're going to talk about the explicit flow measurements. Pull up those.
Okay, have you heard me?
You were very, very quiet.
Okay, I try to. And now?
Still very quiet. I don't know if others can confirm that it's not just me.
Yeah, it is very quiet.
It sounds like you're not using your mic, but some mic somewhere in the room.
I am using my microphone. It's very
And
quiet, or now it's better?
Where you are.
I'm still pulling up the slides.
I try to use the computer microphone. Is better now? Or?
Better?
Now it's better or not?
Slightly.
Okay,
try to speak very strong.
Okay, all right. Slides should be ready in one moment.
Okay, you can share my transparency.
Yeah, it was just uploading in MeetEcho. Here you go.
Okay. Next slide, please. Okay, the explicit flow measurement, short summary about this new kind of techniques is a technique that employs few marking bits inside the header of each packet for loss and delay measurement. The metric described in this draft are the RTT, the delay bit with the new one, the hidden RTT option, the round trip packet loss, the one-way packet loss. There are two options, square bit and loss event bit, and the square bit plus reflection square bit. Next slide, please. Okay, there are some implementation of these techniques. There are a group, a quick measurement group, the project during the last hackathon. The implementation that are now in the lab, someone also in the field, are the Telecom Italia implementation. That is an Android mobile phones probe that implements this technique. The Ericsson implementation, core network probes that are already deployed in some telco in United States and so on. The Orange Akamai implementation, there are in the Akamai production CDN and core network probes. And the new one, the Ake University implementation, they presented yesterday a paper in the ANRW about packet loss measurement. They compare the four kind of bits for this kind of measurement, the L, Q, R, and T bits with the pro and cons for each one. And also Huawei is working on the topic. Next slide, please. The draft updates are mainly two. There are an improvement on the Q-bit R bit about the burst loss resiliency. Now there is the correct detection of burst losses of 2 Q blocks before up to 1 Q block in the previous version. And the main update is about the new option in the delay bit implementation, the hidden delay bit that permits to hidden the RTT in some cases. I will explain better in the next transparency. Next slide. A short summary about the delay bit. The delay bit is a single bit RTT measurement like the spin bit. It's based on the single marked packet. So a packet is marked by the client. The delay bit sample is the market packet, and this packet bunches between client and server. If the packet marked is lost, the packet will be regenerated. There is also a threshold on the reflection time in order to keep the error in this measurement under 1 millisecond. If the reflection time is more than 1 millisecond, the sample is discarded by the client or by the server. The server knows the maximum time that is possible in this measurement, the Tmax. So if two every consecutive delay sample are a distance less than the Tmax, the measurement is all right. If is equal or greater than the Tmax, the measurement is discarded because the two delay samples are not consecutive but are a new measurement. The delay sample is recreated. Next slide. Okay, the improvement that we put in this new version of the draft is the hidden RTT version. Because the spin bit is standardized but often not implemented for privacy reason, because the RTT value could approximate the client-server distance. So it's considered a privacy violation in certain world. There is a simple way to hide RTT and to allow only observer-server entity measurement or inter-domain RTT measurement. The idea is to slightly modify the delay bit implementation, adding a fixed amount of milliseconds to the RTT measurement. In practice, the client does not reflect immediately the delay sample, but wait for an additional delay before reflecting the marking. So, as you can see in the figure, the client, when received a delay sample, waits for an additional delay. So the RTT is incremented by this additional delay. So only the right RTT or the inter-domain RTT that you can see in the next slide is correct. Next slide, please. Some consideration about the additional delay. Our idea is this additional delay is a system parameter of the client. The value is equal for all application sessions, so it doesn't change. The additional delay value is set when a client is switched on. It's a random choice in a range of values. It could change when the IP address changes. Our suggestion is the additional delay choice could be implementation dependent, not standardized. And an observer does not know if it is a normal delay bit or delay bit implementation or an hidden delay bit implementation. So there is no way to understand if this additional delay is added to RTT or not. Next slide. This is the two correct measurements that are independent from the additional delay. The right RTT between the observer and the server, because the additional delay is only on the client side. So when a packet passed through an observer, reached the server and came back, the right RTT is correct. And the second measurement that is correct is the intra-domain RTT between two observers. So if I measure the timestamp when a market packet passed through an observer, reach the other observer, reach the server, come back, and so on, it's possible to have the RTT between the two observers, and the additional RTT is not affected the measurement. So the measurement is correct. Next, transparency. Next slide, please. Okay, in this table is summarized the pros and the cons of the three techniques about the RTT measurement, the spin bit. That is very high the number of measurement, because every RTT there is a measurement, but the impairment resiliency is quite low, because is in case of losses or in case of out of sequence, the measurements aren't correct. The standard delay bit, the normal delay bit that we presented in the last version of the draft, is very precise, but the number of measurement is only medium, because when there is a application delay greater than 1 millisecond on the server, on the client, the measurements are discarded. Indeed, the delay bit, the control of the application delay, the time of the reflection is only on the server, because on the client is unuseful, because the client added already a additional delay, so the discard of the measurement are less, so the number of measurements are greater than the delay bit in the normal version. Okay, next slide. This is the summary about the loss bits that we already presented in the next IPPM meetings, so we can go on. Next, transparency. Okay, in case of 3-bit explicit flow measurement, if there are only 3 bits for explicit flow measurement, there are many options. The last the last option are the use of the delay bit. It's possible to use the delay bit or the hidden delay bit because it's only a different implementation, but all the characteristics is the same about the possibility to hide the RTT. So it's possible to use the delay bit with in the two versions, normal or hidden delay bit, with the other two bits deputed to the packet loss detection, qubit and L bit or qubit and R bit. Next transparency. Okay, explicit flow measurement are gaining interest for encrypted transport protocols, already discussed in many groups, Quick Working Group, TSV, WG Working Group, and so on. There are some implementation from many companies that tested in the IETF hackathon, and there is a thread on the IPPM mailing list. Now there is also a paper that going deep with the analysis of packet loss that the Athens University presented yesterday in the NRW. And so we request again the working group adoption if possible. Welcome questions and comments. Thank you. Okay.
All right, thank you. We are out of time on this one, but if anyone does have comments or questions, we'd love to hear it. Martin.
Yeah, hi, Mauricio. Thanks for this. I guess I've not been following this closely since we decided on Spinbit all those years ago. There's like a lot of options here. I don't know if there's. I mean, to be honest, I've not read the draft to know if it's been a little more clearly there. But I think it's. I think like many drafts, including some that I've written, like there's a lot of it sort of crept into all these different use cases, and I think some like ability to maybe have a recommended choice or something would be helpful here.
Excuse me. I didn't catch the question. Excuse me.
I think it's, is there a recommended choice option?
Okay. But in our opinion, the delay bit in the hidden version can preserve the privacy of the client because the distance is masked because we add an additional delay, and in this case can be, in our opinion, it's possible that respect the spin bit, more companies decided to implement it, but it's only our idea. I'm very curious if other people what are thinking about this idea. If the spin bit lack of adoption depends from the privacy problem or depends from other problem, I don't know. If it depends from privacy problems, the delay bit in the hidden version can answer to this question.
Yeah, so I think we're out of time for this right now, but this does sound like something that would be good to spin up a thread on and include Quick on as well. So maybe the authors could try to kick something off for that via email.
Yeah, that'd be helpful.
All right.
Excuse me. Yes, the spin bit is already standardized. Okay, this is only a proposal for other protocols of new version of Quick.
Right. I understand, but still getting some input about the deployment and how that would guide future bit usage would be useful. All right, I think we do need to move on now. And next up, we have the hybrid two-step update. Let's see.
So this is update on a hybrid two-step telemetry collection method draft. And can we go next slide, please? So what we updated, we added max length field and defined it's a result from our discussion with Frank on flow identification examples, provided more specifics in some environments like SFC, NSH, and when IOM. And resulting from a discussion in RAW, we added mode for hybrid two-step that we now can refer as a upstreaming. And that was result discussion with Pascal, and Pascal agreed to join in the work as a co-author. So welcome, Pascal. And next slide, please. Let's go in specifics of updates. So again, as mentioned, max length field was added. In discussion with authors and some others of the list, we realized that the transit node may not know their path MTU that their packet HTS follow-up packet traverses. So to identify whether it needs to originate a new the next in sequence HTS follow-up packet, it needs to have this information. That information has to be explicit. So thus, we added HTS max length field as 32 unsigned to reflect the maximum length in octets. So we appreciate your thoughts, comments, and probably on a mailing list. Okay, next slide, please. So upstreaming. It was very interesting to learn in a discussion of OEM in constrained environments like deterministic networking or reliable available wireless, that their originally defined the mode for collecting telemetry can be characterized or referred to as downstreaming. So that usually our packets that go unidirectional path from ingress to egress, which is a downstream, and follow-up packets, that's the name, they follow the trigger packet. And especially in RAW, there was an interest in allowing to collect their telemetry information and make the ingress node aware of experience that data packets, so how they were treated by the network. Because especially in the wireless, their node can adjust how it uses available resources in terms of frequency and other parameters, so to optimize the quality of the service. Of course, it does not exclude collecting information for analytics elsewhere for orchestrator or central controller, but they have an option to do this for the ingress. That was interesting and beneficial. So thus we introduced what now we refer to as upstreaming hybrid two-step, where the egress can construct the follow-up packet without the trigger packet, and using the path engineering techniques define the nodes that would be traversed by this packet. So that packet will follow the same co-routed path as followed by the data packets that present their monitored flow and collect the information, and then that will be delivered and consumed by the ingress node. So the ingress node, yes, it can consume it and just use it locally, or it can use it locally and then export it to the data lake for analytics. Any questions about this scenario? Okay, so we probably can discuss it on the mailing list. And the next slide. So the characteristic information. We had a discussion with Frank about what characteristic information can be used by the follow-up packet and by HTS method. So one of their methods, it's basically environment specific. For segment routing, it could be a list of SIDs. For service function chaining that uses network service header, it would be a base header, service header, and context headers, as they are present if the context header are present in a data flow that's being monitored. And in IAM, it could be IAM trace option. So, but their intention is, the plan is that once we have a stable base specification, that applicability to different environments will be defined in separate documents. Next slide, please. So with that, we welcome your comments, suggestions, and discussion. And we believe that the document is stable, and especially since now we have additional use case that is interesting for environments that can be characterized as a resource constraint, DetNet and RAW, we would ask the working group to consider adoption of this document, of this work. Thank you.
Any quick comments or questions on this? I know we've talked about it for a while, so I think it's probably not new to a lot of us. All right, sounds good. Yeah, I think this is one that we will queue up for an adoption call.
Thank you.
Thank you. All right, so now we are on to some of our quick lightning talks. In order to get through a lot of them, I would ask that people can stick to the 5-minute time. So let's start out with Lini's. Just find that deck. And Alina, did you want to share your screen yourself? I saw. Yep.
The official clock, since 5 minutes is hard to keep to, and it's easy to lose track. But
yeah, that's good. All right. Well, let's start it once we actually get going.
I can restart it. That's fine.
Yeah.
Hello?
Hello.
Okay. All
All
right.
right.
Oops. No, I'm sorry. I'm pushing the button. No, I'm pushing the wrong.
Grant, I can grant your screen.
No, okay.
Oh, we lost it. All right. Let me just see if I can share the slides myself.
Yeah. I think that'll be okay.
All right.
Yeah. On my.
There we go.
Yeah. Is it kind of echoey?
You're pretty choppy. I'm losing your audio quite a lot.
Okay. Is it?
Still choppy.
Still choppy. Okay. Hold on. Oh no. My microphone is really.
Yeah, we may want to come back.
Yeah. Why don't
All
you
right,
come
so,
here?
Yeah, let's
Okay.
come back. You drop a note in the chat when you're ready.
Okay.
Let's switch over to Al. All right, Al, just 1 second.
While this is coming up, how's my audio?
I can hear you fine.
Oh, that's wonderful. All right. So I'll just start talking. Yeah, I can see it now. Thanks. So we managed to get the one-way IP capacity measurement draft approved, and it's even at the auth 48. But it really requires a protocol, the way we described the method. And so, we're trying to standardize that now. It was helpful to be able to separate functions into the protocol and the method too. So we know the answers to the two exciting boxes at the top there, or smashes at the top. We know how to begin things. We know what information is communicated. What we really want a little bit of help with is what security features are needed, and how should the protocol operate in different modes. Next slide, please. There we go. So we've basically got 3 phases here. And you can see them, the client and the server are illustrated here. You can see them going down the page: the setup exchange, the test activation exchange, and the test stream and feedback exchanges take place after that. And we start out communicating with a well-known port, and we authenticate. And the response to that is it includes an ephemeral port, which is probably the most critical information in the reply, other than accepting the test and so forth, because the ephemeral port is the new port that we're going to use in all future communication. And all of this is on UDP, all right? So, so then the test activation exchange is basically the offered testing parameters, and we're going to affirm or replace those parameters when we get them at the server. And then the interesting stuff starts, where we actually make the test measurements with the load at PDUs. They contain the usual stuff of test timestamps and sequence numbers. But the feedback messages, which come across, are the actual measurements of loss and delay and received rate, or a sending rate structure where the server, under certain circumstances, is commanding the client, here's what you're going to send, here's the rate you're going to send next, and how you're going to do that. Next slide. So what we really want to know is what security features we want to add to these exchanges. And in the past, we've done work with multiple modes of operation. Right now, in the running code, we've got an unauthenticated mode, basically for all phases. And we've got an optional authenticated setup only. And so those are kind of modes A and B combined. It would be fairly simple to encrypt the setup and test activation phases. That would be option C or mode C. And because there's only 4 packets in the total group there, even though it's 2 phases, and they're low rate, very easy to do. But it gets challenging when we go to the test stream and the feedback streams. We think the next most likely or possible stream that we could encrypt would be the feedback messages. And that's where we're protecting the messages that have the measurements in them, but also the commands for new rates. So this is a likely high hitter for something where we want to encrypt. And then integrity protection on the test packets, and then finally encrypted test packets. But I mean, anything we do with the test packets is going to be really challenging. We're going to be over 80,000 packets per second at 1 gig, and a lot of little boxes, and CPE aren't going to be able to do it. So we're interested in feedback on number one, whether these are the right modes. And we think it's a pretty good guess at this point. But if we want to add or subtract a few, we could do that. And then the last thing we want to know is what's the bulletproof solution for security that isn't going to get us into any trouble at all during IESG review. In other words, we'd like to do it right once and then be done with it. And then it'll go in the running code and everybody will be happy. And with 6 seconds left, I'd be glad to take your comments in the chat. Thanks a lot.
Thank you so much, Al. Thanks for sharing this with us. If you have questions, go in the chat and we can carry this on list too. All right. Nalini, do you think you're good now? All right, can you try talking? Oh boy. Very, very, very quiet. Lots of static. Okay. I think we're gonna need to come back to you again. Apologies for that, everyone. I think next we have the on lag documents. And let me just pull these up. What's going on is that some of the slides that were updated more recently are not showing up in Meet Echo, so I'm needing to upload those again. Go. All right.
Okay, hello. So can you hear me?
Yes.
Okay, great. So I'm going to present this performance measurement on link aggregation group on behalf of the co-authors. So next slide, please. Next slide, please. Okay, so, here's the background about this draft. Originally, we started the work in a single draft, which include the solution extension to O1, T1, and stamp. And after the discussion on the mailing list, we received some suggestions from the mailing list to, it's better to, split the draft into two drafts. The first one is just focused on the stamp relevant extension, and the second one is focused on the O1 and T1 relevant extensions. Next slide, please. So here's the motivation for this work. So as we know that link aggregation group is widely used in the field, and it combine multi-phasic links into a single logic link. So it can provide higher bandwidth and better resilience. But the current, active IP performance measurement tools only view or lag as a single logic link. That means the measure metrics only reflect the performance of one member link or the average of all member links of the lag. But in some cases, the delay of the member link of a lag are different because the member links traverse different transport paths. But there's a requirement, to provide low delay services to time-sensitive traffic. So it's necessary to know the link delay of each member link, and then we can steer traffic accordingly. And this two drafts define, relevant extension, OWAMP, TWAMP, and stamp to implement the performance measurement on particular member link of a lag. Next slide, please. So here's extensions to the stamp. For the stamp extension, there's no changes to the base test packet format. We just define a new TRV, which is called lag member link ID TRV. It is used to carry the relevant standard member link ID and the reflector member link ID, which are used to, to validate whether a test packet is received from the expected member link. Next slide, please. So here is an example how stamp microsession works. There are two hosts, A and B, are connected by a lag, which consists of three member link, 1, 2, 3. And then we can, to establish three microsession on the lag. That means for the one microsession 1 for member link 1 and 2 for 2, 3 for 3. And when starting the stamp test packet, host A send the test packet over member link 1 and with the sender member link ID to the reflector, and host B associate the test packet with microsession based on the for tuple and plus the member link receiving member link to correlate from which microsession the packet is received from. And after process, B send the reflected test packet over the member link 1 back to host A, and with the sender member link ID copied from the previous received test packet, and also set a relevant reflector member link ID to host A, and in the subsequent test packet, host A can set the value of the reflector member link ID. Then B can use that ID to validate whether the packet is received from the right member link. So that's an example of this idea. Next slide.
think we are out of time.
Okay,
Rakesh,
it's not, yeah, it's the last per slide. I think you have a question.
May I ask one question? So only question I have is that instead of creating a micro session, why not just create a stamp session for the member link, and then you know from the session ID, is this for the link 1, 2, or 3?
You can do that, but you have to configure one by one, right? You need to configure for a single link to to establish your stamp session. But with this one, we just to enable it's just to simplify the configuration. It's I think, in my personal opinion, I think it's a better way for the operator to to enable this function.
Yeah, if you could elaborate in the draft, the motivation, that would be good.
Okay. Greg, do you have some comments to to add?
We may want to take this.
It simplifies configuration, and it's similar to micro BFD 7130, where it presented as a single session on constituent links. But in effect, as Rakesh, you suggested, it works as a separate sessions with the different SIDs. But so additional TOV introduced here, it's just a way of instrument of ensuring that exchange occurs on appropriate member links.
Yeah, but, be good to verify
the philosophy is similar to the micro BFD RFC.
Yeah, thanks, Greg and Mac. I think it would be good to document, clarify in the draft the motivation. This kind of things are useful.
Thank you for your suggestion. Yes, certainly.
Okay, thank you.
Thank you, guys. We are over time, so we'll move on. Appreciate it. All right. For this next one, Giuseppe? Yeah, thank you.
Hello? Can you hear me?
No, we can't hear you.
Hello, can you hear me?
Yes.
Okay. Yeah, this is a 07 version of this draft about enhanced alternate marking. So next slide. We didn't get a chance to present during the latest IETF meetings. Anyway, just a quick recap about the motivation. Maybe you know the alternate marking technique. So the reference document are RFC 8321 and RFC 8889. That is used to measure packet loss, latency, and jitter, and also the extension for multi-point unicast, that is the RFC 8889. However, there are some pending points to explore, since now we are moving to the standard document for these experimental RFCs, in particular for IPv6. And so we met some, let's say, deployment issues. That's why we came back to IPPM to discuss how to enhance this methodology. In particular, from the deployment experience, we learned that we need some flow monitor identification. We also need to figure out how to implement the alternate marking framework, including the multi-point measurement. And in the future, for further extension must be considered as well. So next slide. Yeah, this is a recap about what is the current standard data fields for IPv6. So we defined the alternate marking option that is expected to be encapsulated as op by op options or destination option header. You see that in addition to the two marking bits that are loss and delay bits. We also have the flow monitoring identification field that is required in order to help the configuration, to simplify the counters handling, and also to facilitate the data export and correlation. In any case, we choose this 20-bit flow monitor identification, but there is a 50% of chance of collision for just 1,200 flows. So if you need more entropy, maybe the size could be increased. Next slide. For this reason, we try to enhance the methodology by extend through the next header by adding new fields in order to allow advanced applications. For example, additional 20-bit to extend the entropy in case you have to do large-scale measurement if needed, additional flags for special purpose usage, or other metadata that can be attached for enhanced functions. Next slide. Yeah, this is just to mention possible possible usage scenarios for these enhanced capabilities. For example, we can have shortest market periods, so we can reduce the marking period, also the accuracy of the methodology. We can have more dense delay measurements than double marking method. We can also increase the entropy of the flow monitor identification. We can also automatically set up the backward detection and so on. So further extension may be considered, may be explored with these enhanced capabilities. So next slide, I think is the last one. Yeah, so we hope to have some comments. As I said, the work in 6 months is in IETF last call. So, and we aim also to discuss this enhanced activity also in IPPM. So thank you.
All right, thank you very much. We are out of time. So if you, take any comments or questions to the chat or to the list.
Okay.
Okay, Nalini says she can try one more time. Different mic. Try to switch to that. Do you want to try talking, Nalini?
Now?
I can hear you. Can you talk a little bit more? It sounded a little choppy, but we could hear you.
Okay, let me see if I can.
Oh,
okay.
yeah.
That sounds
you guys
good.
hear me? Oh my God. Yeah.
Okay, let me
Technology.
find the slides again. Oh, where'd they go? Here it is. Go for it.
Okay, thanks. Okay, so yeah, next slide, please. Okay, so basically, this is an extension to PDM RFC 8250 because we need the performance data, especially at enterprises, and because PDM is not limited to an administrative domain, then we have more sensitivity to potential misuse of the data and the metadata. So we need encryption. And so what we propose a lightweight, what we believe is a lightweight and scalable methodology, and maybe other folks want to use it too. Okay, next slide. So how can you misuse PDM? Well, you can learn the possible weak points, because we've got good performance data. I mean, that's the idea, right? And trigger inappropriate network management. Okay, next slide. So basically, what we have is a registration phase and then a data transfer phase. Registration phase you do beforehand, and of course you can go encrypted as well as unencrypted. The registration phase is you create a shared secret, and you do it just one time, and then you don't. So you're not doing that during the course of the of the data transfer, because otherwise you get into a whole bootstrapping problem. And so every once in a while, there'll be an occasional key derivation to redo the keys. Okay, next slide. So, okay, so this is, it's a little hairy, and, you know, we talk about it a bunch. Basically, the idea is the green paths, that's the data transfer, and that's all encrypted. That should be as fast as possible. And the way we make it fast is we have these shared secrets, and we have the idea of a primary writer and a primary reader, you know, for both the clients and the servers. And all that stuff is done well beforehand. And everybody, you know, gets their little secret to hold on to, you know, before all this stuff starts. And then all you have to do is just rekey once in a while. So yeah, so that's kind of the idea. And as I say, we had a whole big long session. We had an hour-long session before all this, and I have the recording and quite a bit of interest in that. I will write up all the questions and answers and the changes from that. Okay, next slide. So why are we doing this is because usually at the enterprise, because enterprises are huge end user sites, because that's what this is all aimed at. PDM is aimed at end user organizations, not really the folks in the middle. And we have lots and lots of servers, lots and lots of clients in maybe a lot of different locations. And you want to keep the complexity and overhead down. Otherwise, there's a ton of keys to keep track of. And also remember, this is how do I say, this isn't the IP layer. And so you want to be real careful about how much you burden the IP layer with anything. Okay, next slide. So we're using HPKE, and again, you can see like the heavyweight stuff is done in registration, and then every, you know, at a max, every 2 to the 15 packets, we rekey. And then, so online, so you just have to do encryption and decryption with every packet. And there's a bunch of discussion in the side meeting about how often should you do it, how often should you rekey, and so forth. And of course, that's, and you know, what kind of shared secret, and that's all, it's all underway. And we will revise according to the feedback that we got. Okie dokie. Okay, so next slide. Okay, hey, huzzah. Yeah, and so do send questions on the list, and we hope to have an implementation by Madrid, and if it's live, then we'll show it to you live. Otherwise, you know, we'll show it to you, we'll post demos on the list. And I think I have 6 seconds. So thank you guys all so much, and thank the Lord my mic worked.
Thank you very much, and I'm glad we were able to get your mic working after all.
Yeah. Okay. Thanks, guys.
Yep. And for people who are interested, yeah, please, I guess, check out the recording of the earlier meeting that was referenced there and comment on the list. All right, we are out of time for this session. There were a couple lightning talks we didn't get to. People can still learn more about those by looking at the slides that are posted in the materials section for the meeting, as well as asking questions on the list, which is always the right place to go to. All right, does anyone have anything else they'd like to cover, or if not, all right, thank you so much, everyone. We will see you on the list. We'll get some adoption calls coming out soon, and we will see you next time. Take care, everyone.
Thank you.